Hi, I'm Ivan. Do these weekly videos to share what I'm learning about Harper as I'm going. Last week, we talked about MQTT and I showed you a little bit about how to get started with that. This week, I'm going to show you a little bit more in that same venue. The plan here is you learn how to use Harper with MQTT, then you learn how the other functionality around MQTT and PubSub works with real-time messaging in Harper. And then we'll build a couple of apps on top of that, something that might look like an MQTT broker that's embedded in Harper, and also the LED controller that I talked about a couple of weeks ago when I was back at my other location, coming at you this week from an undisclosed location in the Pacific Northwest that is a little wet at the moment. So sit back, grab a cup of tea, and let's talk about MQTT this week. I've shared my screen. You should be able to see my terminal here, my editor with the GitHub repo. This is the actual GitHub repo, so you can find it at Harper Fast, MQTT getting started. This is me with it running in my local editor. Here's the Oasis site on MQTT, mqtt.org that we talked about the first time. A couple of things we're going to walk through over here, and then this is me looking at my local machine and what's going on here. So let's start off with MQTT as a standard. So we talked about what it is and how it works, why it's really nice for the edge, how it is low overhead, and it's about telemetry transport. That's the TT in MQTT, message queuing telemetry transport being the full acronym. There's a ton of stuff here in getting started. Uh, there's also the full set of specs. It's gone through a bunch of revisions. There's some software here, and I wanted to point out there are a ton of servers and brokers. Harper is one of them. There are a bunch that run in the cloud. Harper is one of them. Harper can run both locally and in the cloud. And there's client libraries to integrate many different things. You can see Arduino, which is recently acquired by Qualcomm, small device controller, ESP-Duino for using Arduino with the ESP8266. ESP8266 is a microcontroller from a company named Espressif. They make a whole collection of hardware. Mbed is another runtime for edge devices. All of these are runtimes for edge devices. So if you're building a smart thermometer or a smart light bulb or a smart birdhouse or whatever it is, this is the software that you would embed in your stack in order to make those devices talk to the broker. And you can see there's support for all the languages you could ever want, including things like Dart, Clojure, Erlang, Haskell, things you would never run on the edge, but it's fine. And then useful things like Lua and Perl, Python, things like that. So there's a ton of software here. Let me scroll back to the top. Those are client libraries. And then there are tools and applications. And I want you to pay attention to this because I'm going to show you a couple things at the end related to some of these tools and applications, because you might notice this right here, MQTT Explorer. We talked about that last time. That is another tool that we're going to look at again today and see how it works with what we've got in Harper. Okay, so without any more delay, let's talk about what we're doing this week with Harper. Let me open this site and go to our real-time docs, and let me show you something interesting. On this side here, you can see we talk about real-time and content negotiation, and we talk about protocols. And under protocols, we have MQTT. We talk about topics and ordering in MQTT, and then we talk about WebSockets and server-side events. So these are different protocols that you can use to do PubSub and real-time PubSub. We've got documentation here on how it works. Here's the MQTT bit that's on by default. And then here's what it looks like if we go down to WebSockets. So WebSockets are supported through our REST interface. Remember, you turn that on with the config.yaml directive, REST equals true. So I have them on, which means I have WebSockets turned on. And then by default, making a WebSocket connection to a URL will subscribe you to the referenced resource. And you can see what the URL looks like here, WebSockets service resource. I'm going to go over here, and since Harper runs in Node, I'm going to show you Python for fun. So here's a WebSockets publishing client. And look, there you can see the URI. WebSockets localhost 9926. That's my Harper instance running locally. And there's my topic path of sensor 101. Cool. And this is the publish. If I look over here, it's going to be subscribe. It's going to do the same stuff. And you'll see connected, listening, the payload comes out, and we dump it out with temperature and location. So that's what it takes to connect to a WebSocket. And that's how it works. And this is details about how you work on the server side in Harper to make WebSocket connections work, how you process messages. And then just below that is the section on server side events. Server side events is what I always say. Again, through the REST interface, this is a subscribe only interface. Because it's subscribe only, there's no incoming messages. But you do the same thing. You say, I'm going to subscribe to this endpoint, and then I'm going to get this data. And now looky here, we have a server-side events, server send events Python script, which takes that same URL, but notice now it's HTTP, not WS, because it's not a WebSocket. It is literally an HTTP connection. Using requests to open an SSE client, streaming client. Notice stream equals true, so we're going to stay open waiting for them. And then every time we get an event, we're going to print it out with the payload. It's going to be exactly the same. So what I've described here is Harper sitting in the middle and with zero configuration except turning REST on. All of a sudden, you have now got the ability to send and receive MQTT to Harper, to send and receive messages via WebSockets to Harper, and to receive messages from Harper via server sent events. This is all PubSub, and this can all happen extremely fast, and as we say here, in real time. Let me show you it actually working. So here's my Harper server. Got some bugs. I got some audit things because I have logging turned way up, so there's a bunch of audit messages. But let me just kill this and show you. I'm running Harper dev. I'm running that out of this directory where I have a schema.graphql and rest equals true. Now, what's in my schema.graphql? You remember last week we built the sensors table and we were fiddling around with making a root topic table in order to make messaging work with open source tools. So that's what we've done here. We've created a topics table and we exported as the blank so that wildcards will work without any base name, without any root path. And then we've got a sensors table. And here you can see our ID, location, and temperature. That's all we've got. So now I'm going to run this. I'm assuming my computer will wake up and do the right thing soon. Over here, you can see nothing is going on. So I am going to drop this database, which I won't be able to do until my terminal wakes up. We're waiting. There we go. All right. So now that's running. Now I can do drop database. I'm just going to run it again. So we reload from the schema.graphql. And then if I go reload here, you'll see data, sensors, topics, there's nothing. So that is exactly what we would want. Now, over here, I'm going to run a node MQTT publisher. Connects to MQTT, starts sending messages. Boom, there we go. Now, if I come over here and I refresh, there's you can see 97.2, 97.2. Messages are flowing, and if I hit refresh, it continues to happen. Now over here, this is my Python, not Node, Python MQTT subscribe. Launch that, boom. I start seeing the messages coming through. And this will match because it's sending them every 5 seconds. Now, I left that running. You can see it updating in this tab. Come over to this tab. I'm doing I'm going to do a WebSockets subscribe. Still seeing the data come through. Boom. Here's the MQTT. There's WebSockets. Now in this one, we're going to do server-side events, server-sent events. This is all Python, but now you've got an MQTT publisher, you got a MQTT subscriber, you've got a WebSockets subscriber, and you've got a server-side events subscriber, all in Python. Now over here, we're going to run the MQTTX. I didn't do this last week. I didn't have the Python parts working. I didn't have Python installed and running. Now I've got Python. Now we're going to run the shell. So we're going to do shell subscribe. Now you can see I'm getting the same thing. The temperatures are coming through via on that. Finally, we'll go to the node side. Let's do the MQTT first. Same thing. There we go. It's all just flowing. Now we'll do the WebSockets. I probably said web services a bunch when I meant WebSockets. That's because I'm old enough to have lived through Schema and WSDL and all of the stuff, which was wild in a way. There we go, server-side events. So there you go. We've got Harper running in the middle as a broker, and it's not just a broker, it's saving stuff to data store on the back end. You saw that here in the table. And through almost no configuration at all, just turning REST on, we've actually got WebSocket support and server sent event support in addition to the MQTT configuration. So what you've got is the MQTT publisher sending to the broker. It's getting stored in the table on the server, and it's flowing through to all of the clients using any of the subscribe protocols that are supported by Harper. Server-side events, WebSockets, and MQTT, and updating the table. So if you were to build an app on top of this, the last and most important thing that we'll get into, and this is the hook for building the apps, is your app can actually receive events from the tables natively within process, doing a bunch of PubSub inter-process communication. And so next week, when we build out a little app that looks sort of like a broker sitting on top of Harper, we'll be able to see how that application is actually getting data communicated it from the lower levels of Harper in the data store and the caching layer via messaging all the way up to the user interface. All right. That's the show for this week. That's everything we've got. Let's remember to take a breath and be thankful for all the things that we've done and we can do. Let's remember that Harper is built by a wonderful team of engineers who hopefully will take some time off over the next few weeks during the holidays and come back in the new year refreshed and restored, knowing how grateful we are for the wonderful software and the awesome platform that they've built for us to build apps on. With that, I'll close. Thank you so much. Have a great week.